Hi guys, we are going to finish the 2018 examination paper, level 2 organic chemistry, finishing question 3 today. So as always, if you're not subscribed, smash the subscribe button, leave a like, and let's finish this exam paper. All right, first question. The graph shows the trend in two physical properties, of alcohol. I didn't know the trends shown on the graphs above. This is, I'm just going to verbally say it, the number of carbon increases as a number of carbon atoms increases, the boiling point increases, the solubility decreases. Okay, there's no explanation required. The number of the boiling point, that's more of a level 3 thing, that's intermolecular forces. Solubility, it's just that, if you think about a alcohol that looks like this versus an alcohol with, let's say, 8 carbons in the middle, and then as you can see, the more carbons there are, remember the carbons are the non-polar part of the molecule. The more non-polar things you have, the more significant they become, and the more non-polar the thing is, and the less soluble they are. But in general, just remember, as the number of carbon atoms increases, the solubility decreases, so boiling point increases. All right, next one. I think this is where the bulk of the question comes in. All right, reacting with potassium can produce 2. Okay, so this is a major minor product. So you got 2 chloropropane. So you got 2 chloropropane, which is this. Now, you identify the conditions. So KOH, you can do 2 things. You can react with KOH aqueous, and then, oops, let's just do that later. And then you can react with KOH alcohol. And I kind of mentioned, I can't remember if I mentioned this before. I'm pretty sure I have, because this is my go-to analogy to use. If you dissolve your KOH in water compared to your KOH in alcohol, when you are putting in water aqueous, think about, you are drinking water. Why do we need to drink water? To to keep adding fluid into our body to replace the fluid that we lost. So this is a substitution reaction. So, okay, so you're kind of putting good new water in, and then you go to the bathroom, you let old water out. Okay, so this is a substitution reaction. You get the point. KOH alcohol, this is a elimination reaction, because when you're drunk you lose stuff, so that means the Cl has to go. Then you either lose one of the H's. It actually makes absolute no difference which one you lose, because you have the same product. Okay, so the type of reaction, this is substitution. Why is it substitution? And this is the thing, I just tell people, try to not to memorize everything, try to understand. You can see the Cl is replaced by the OH, whereas for this one, the Cl is lost, this H is lost, and then you made the double bond, which is elimination. Elimination is making double bond. Okay, so this is substitution, this is elimination. Very straightforward. Just remember the KOH AQ, an alcohol condition, then you'll be all right. So let's have a look. So this is a dilute aqueous, and the other one, this is a substitution reaction. Cl is replaced by OH group, but then if you use KOH alk, you have elimination reaction, you remove atoms, then you form a double bond. Okay, very straightforward. Let's move on. This should be the last question of this exam paper. Okay, let's see, elaborate on chemical tests that could be used to identify the function groups of the organic products formed in part I. So that's this thing. So we have an alcohol and we have a alkene. Okay, so this is rather a poor question, to be honest, because if you screwed up part 1, you can't do this. This is rather very difficult exam if you didn't know what to do. And this is the thing I always say to my students, organic is something that you can't BS your way out of it, because I used to major in biology and chemistry. With biology, most of it's common sense, and then you can try to link to some of the, you may have no idea what the question is asking you to do, but then you may try to link to something that you know, then you can talk about blah 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 blah. But for chemistry, especially organic, if you don't know it, you don't know it. Okay, there's only one correct answer. You can't you know, BS your way out of trouble. So unfortunately, have to learn it. So we have, just remember, we have this, and then we have this. Okay, just before I forget. Okay, identify. So how do we distinguish them? Identify the chemicals and conditions required. So this is an alkene, and with alkene, bromine water is the way to go. When you do bromine water, if you react this with bromine water, then you will have a orange to colorless color change, orange to colorless color change, color change. No need orange colors, that's already a color change. Okay, and this happens straight away. We did this in part 2 of the video. I just did it 5 minutes ago. Okay, now if you react this guy with bromine water, there's no reaction. Oops. And what do we mean by no reaction is that, now this is something that you need to understand. When there's no reaction, this thing stays orange. So you can't just say no reaction. How do you know there's no reaction? Because the color doesn't change. Okay, so bromine water is a bad thing to talk about. This is an addition reaction, and then you have broken the double bond, then you added the 2B-arsen. So if we want to draw this reactant, the products, you just draw this, which is again very straightforward. Okay. All right. Now explain why potassium permanganate solution, which is KMnO4 aqueous, cannot be used to distinguish it. Now KMnO4 is actually a really interesting oxidant. If you have COH, now again, I feel this particular question is very nasty, because we've always talked about in level 2 chemistry that the primary alcohol can be oxidized into carboxylic acid. We don't actually teach you about this. I mean, we kind of do, but we don't emphasize it. This is a secondary alcohol. If you react with a secondary alcohol, I might just do it now, might as well. If you react the secondary alcohol with the permanganate, ion, it will oxidize as well. You will make a, so you know how with, let's say if we do this is this thing that I just drew, this is a year 13 molecule. Okay, this is a ketone, but you don't need to know that. Let's say if we have this is something more familiar. If we have a primary alcohol, this will be oxidized into a carboxylic acid. So you always gain this double bond O. Can you see you always gain this double bond O? But the key thing is this will have a reaction. This will oxidize, oxidation reaction, and then you will see a color change from purple. The potassium permanganate is purple, and then this will change to brown, which is the MnO2. Because this is not acidified, so don't say colorless. Read the wording. This is not acidified potassium permanganate. This is just normal permanganate. You're gonna go from purple to brown. Now, same thing with your permanganate reacting with alkene. You will form a diol. You will oxidize both of these double bonded carbons, and you form a diol, and then you also see a color change of purple to brown. So you can just talk about that. It is not a suitable reagent because the alcohol and the alkene will both be oxidized, and then you can see a color change from purple to brown. Therefore, it is not a suitable reagent to distinguish it. Now, you do not, I'll emphasize this again, you do not need to draw the products of this particular reaction because that is year 13. Okay, so don't worry about it. Okay, so let's have a look at the answers. So the OH group can be identified with a warm acidified from orange to green, redox reaction. Okay, or you can say the double bond can be added. So you can see if you react one or the other, I can just say if I have these two things, if I know one is an alcohol, one is a One is a primary alcohol, one is alkene. I can use bromine water. That allows me to distinguish colorless, goes from orange to colorless. That tells me it's an alkene. The other one must be alcohol. I mean, if you want to be more safe, you can say put in acidified potassium permanganate or dichromate. Then you're going to see a color change from either purple to colorless or orange to green. Okay, so it doesn't matter which one you use. But then KM104 cannot be used because you react with both reactants. Okay, so this is a ketone. You don't know what that is until you do level 3 organic chemistry. So no point to worry. It changed from purple to brown. Colorless is okay, but brown is far more correct if your solution is not acidified. Okay, so hopefully you have gained better understanding of these of this particular topic. I will be, like I mentioned before, I'll be going through some other 2018 examination papers, probably some level 3, some level 1s, and then once I've done those, I will move on to the 2017 examinations. A few people have asked me, because they quite enjoy my gaming videos, they are not coming until the exams are finished. I'm sorry guys, I do have some content, but they are saved until we finish the business that you are here for. You know, you want to do well in the NCEA examinations, you want to achieve really good results, you know, fulfill your potentials. The gaming part is just entertainment, they can come later. So don't they will happen, don't worry. Okay, so good luck with the studies, and I'll see you guys next time. Bye bye.